All right, thank you everybody for coming. This talk is going to be about how you can connect multiple clouds using Keystone to Keystone Federation. We want to first introduce ourselves.
Hi everyone, my name is Vishakha Agarwal. I am a Keystone contributor working as senior member technical staff at NEC.
And I'm a cloud developer at SUSE, and I'm the newest Keystone PTL. So this is an overview of what we're going to talk about today. We'll give a brief introduction to the idea of what federated identity is in general. Then we'll start talking about what makes Keystone to Keystone Federation special, and talk a little bit about the history of Keystone to Keystone, why we have it, and what it's used for today. And then we'll start doing a more technical deep dive into some of the terminology around identity federation, and specifically to federation in Keystone. And then we'll talk about some of the authentication flows, the actual sequence of steps that happens when you make a request with a federated identity system like this. And then we'll go into how you can configure this type of system from the ground up and do a little demonstration of that working. And then we'll talk about what the Keystone team has in mind next for our future plans for federation and for Keystone to Keystone Federation. So briefly, what is federated identity? It's just the ability to share a single authentication mechanism across multiple systems. And in our case, this is going to be cloud systems. So typically, your organization already has some sort of source of identity, so you don't want to create another set of credentials just to use for your cloud. So regular Keystone Federation allows your cloud to receive that identity information from this pre-existing identity provider. And it's separate from a regular LDAP provider because it's not just a data identity storage system, but it's also a way for users to authenticate directly with this identity system and be able to sidestep going through Keystone for authentication. So what makes Keystone to Keystone special is, in this case, Keystone itself acts as that authoritative identity source, and it provides that information to another Keystone service. So in this type of system, there's no need for an external identity provider. This feature has been around for actually quite a long time. The original Federation implementation was implemented in Icehouse, and then the Keystone to Keystone Federation came along in Kilo. So it's not a really new idea. It's been around for a while, and the original idea was mainly to support hybrid clouds and supporting the types of workloads where you would need to burst from a private cloud to a public cloud. It was thought to be useful for connecting multiple data centers within an organization if you didn't already have some sort of shared identity provider for these different data centers. In practice, as far as I know, this isn't really used that much for the cloud bursting type of scenario, partly because setting this up on the public cloud side is not really a completely self-service operation. You do need to get a little bit of operator involvement from the public cloud side in order to get this running. But it is still definitely useful for multi-site deployments, either within an organization, or you could even connect multiple organizations together with this. And then with the growing importance of edge computing, we in the Keystone team see this kind of Keystone to Keystone Federation as a potential architecture that could allow identity information at remote autonomous sites to remain autonomous without the need for synchronizing data across sites. So now I'll start into the more technical deep dive. So some of the terminology that we're going to talk about today when we talk about this Keystone to Keystone configuration. First of all, the identity provider is that thing that accepts your credentials, it validates them, generates some sort of yes or no response about whether this user really is authenticated. And it returns some attributes about you, like your username or your display name, or also some authorization attributes, like maybe what groups you're a member of. And then the service provider is the thing with the resource that we need. In this case, the service is Keystone, and the resource we need is Keystone tokens. And those tokens can then be used to authenticate with other OpenStack services. It's important to note that for the sake of simplicity, we usually talk about one Keystone being the identity provider and another Keystone being the service provider. But they could be configured reciprocally. You could have both keystones or many keystones acting as identity providers and all also providing services to each other. So if that's the type of scenario that you're looking for, that is possible. So Keystone as an identity provider speaks the SAML protocol. There's lots of different types of federation protocols, but some things like the OpenID family of protocols. But Keystone as an identity provider speaks SAML, which is an XML-based federation protocol. And then a SAML assertion is a XML formatted statement from the identity provider that asserts that the user is authenticated and provides some attributes about the user. That assertion is usually signed and encrypted, so there's a trust relationship built between the identity provider and the service provider. And then Keystone is able to read this assertion, and it uses it to recreate local users, which we call shadow users, based on those attributes in that SAML assertion. So more about shadow users. This is kind of an implementation detail within Keystone. It's a local copy of the federated user's attributes based on that SAML assertion, like their username and also an internally generated ID. And it's used internally to Keystone in a way that makes handling federated users that are coming from this external source, makes Keystone able to handle those users in a consistent way with the same way we handle regular SQL users or users coming from an LDAP backend. And then, excuse me. And then, so a mapping then is it's a set of rules that allows the operator to configure exactly what it means to translate these values from the SAML assertion into values that a Keystone user can understand, or that Keystone can understand. So translating, for example, a user's email address from a SAML assertion into a Keystone username. So it handles identity information like that, but also can handle authorization information, so things like the user's group membership coming from the SAML provider, from the identity provider rather, or any kind of other rules that help Keystone map this user to a set of roles and projects within Keystone. This is what this mapping API is for. And then my last two set of terminology things, these are the main SAML profiles that we talk about. The WebSSO profile is the most commonly used SAML profile. You've probably already encountered it in your organization. It's the authentication flow that's based on the idea that the user is going to be using a web browser to do this interaction with the service provider. So the process is always initiated by a request from the browser to the service provider, and that starts a sequence of steps where the user is authenticated through the browser. I mention it because it's common, because you've probably seen it before, but it's actually not what we use for the Keystone to Keystone authentication flow. What we use is a modified form of the ECP profile, which stands for Enhanced Client Proxy Profile. And that is a profile that's geared more towards the CLI or for SDKs. And we use a modified form of that. And I'll dive into that a little bit in these diagrams. So this is what you would see for the standard WebSSO profile. How this is going to work for this profile is the user's browser makes a request to the service provider, and that starts a sequence of steps where they are redirected with an HTTP redirect to the identity provider. They do their authentication, they fill out their credentials in some kind of web form, and then the browser receives a SAML response from the identity provider that contains that SAML assertion, and then the browser posts that back to the service provider, and finally the user can get the resource they need. So I show that for comparison, but again, this is not what we do in Keystone to Keystone. In Keystone to Keystone, in this case, we actually start with a request directly to the identity provider. And since this is a Keystone identity provider, the first step is actually to get a Keystone token. So the user gets a Keystone token from this Keystone identity provider, and then they use that to request a kind of unsolicited SAML response from the identity provider, and that SAML response contains that SAML assertion. Then the user is in charge of forwarding that SAML response, that SAML assertion, over to the service provider. Then they can get validated, then they get their token, and then they can actually start the process of actually using OpenStack with that token. So now I'm going to hand it off to Vishaka, who's going to tell us how we can actually configure this type of system.
Thanks, Colin. So now we'll see how we can configure our keystones as service provider as well as identity provider. So before moving on, we need some basic keystone installations. We need 2 keystone installations in which one will act as service provider and another one as identity provider. Since we have to log in into the horizon of the identity provider, so we need to configure horizon 2. So we have our installation guide available at this URL. So for Keystone installation, you people can refer that. So before moving, in order to have a full log level, we can also enable insecure debug option in keystone.conf, and which we have to disable before moving on to production. Okay, so let's start with configuring Keystone first as an identity provider. Since in Keystone to Keystone federation, our service provider needs to trust our identity provider. So it's a one-sided trust relationship between them. So we have to generate, for service provider to trust our identity provider, we need to provide our basic details of identity provider to the service provider, for which we need to generate a metadata for the identity provider and pass to service provider, and also to generate keys in order to have a secure connection between both. We also need to tell the keystone of identity provider about the details of the identity provider, in which we have to edit our keystone.conf. So first a user need to assign an entity ID to the identity provider, which is also known as remote ID or entity ID, which is unique to our service provider. So it can be any string, but it should uniquely define our identity provider to the service provider. Next, we have IDP SSO endpoints, which is irrelevant in our case since K2K does not support web SSO for now. Okay, so you can have a look over the example of the keystone.conf for identity provider. So we have a SAML, with the protocol we are using, we have a section SAML in which we have given our entity ID, and the second point is irrelevant for us, but we have kept it because in future we will support web SSO profile too. Third, we need to tell our identity provider where our encryption keys are, and the metadata path which we just generated for our identity provider. So metadata is just a bunch of XML that contains some information about our identity provider. So this is for our Keystone as an identity provider. Next, we need to configure our second Keystone as service provider. First, we have to generate an IDP instance, identity provider instance, over service provider, passing the remote ID or identity provider, the entity ID which we just created before, which we just assigned before to our identity provider. In order to look what we have assigned, what entity ID we provided, we can grab it by making a curl request to the metadata endpoint of the identity provider. Okay, so now we have to create a local group in our Keystone as a service provider, so that we can map our remote attributes that are being coming from the SAML response from the identity provider to this group. So we need to create we are just creating a local group in our service provider and assigning some roles to it. This is just to we are doing it just to give some of the authentication to our remote users in our local Keystone. So this is a mapping file that we just created in which our remote attribute OpenStack user is getting mapped to the local username, and hence we are assigning it to the local group that we just created, federated users. So this is the simplest mapping we just used, and we have different type of mappings which we can use. Now with the help of Keystone CLIs, we have to give a name to our mapping where we will pass our .json file that we just created. And next we have to create the federation protocol which will link our mapping to the identity provider, that the object that we just created before. Okay, so user have the option to decide which Apache module he wants to use for our service provider. So here we have used shibboleth, modeshib as an Apache module for our service provider. Since Apache is already configured during the installation of Keystone, but shibboleth do look for some primary options into shibboleth2.xml. So we need to edit our file shibboleth2.xml we need to insert 3 datas in it. First is the entity ID of identity provider, the unique ID that we provided to our identity provider that uniquely defines it into our service provider. Second is the entity ID of service provider. We need to assign a unique ID to service provider too. Thirdly, we have to give the metadata URL, metadata endpoint of the identity provider. We also need to add the remote type attribute that was OpenStack user in our case to attribute map.xml. So shibboleth do generate some of the log files for errors or warnings if occurs. So we can check that in that log files. So every time the user hit these authentication endpoints, the user first should be redirected. Should be authenticated with the federation protocol before moving to Keystone. So to enable the proper routing through modeshib, we have to edit our vhost file of Keystone and add some of the location directives to it. So it generally states that we have to run shibboleth and an authenticated user is acceptable to it. We also need to tell our Keystone that a federated login will be there. We need to edit our keystone.conf of service provider, and in the auth section, we need to add what protocol we are going to use. So this, now finally, we have to link both the keystones, one acting as service provider and identity provider. Since our service provider is configured, we need to create an instance of service provider 2 in our identity provider. So we can use the OpenStack CLI by passing the auth URL, which is the authentication web endpoint of our IDP, and the service provider URL, which is the binding URL for handling our ECP request. So to get the binding URL, we can also make a curl request to our metadata endpoint. So after doing all those configurations, we are now ready to check our setup, is it working fine or not. So we have this CLI, we can use the this Keystone CLI to generate a token from the identity provider for the service provider. So we need to pass our service provider and the remote project names. So a user first can get an unscoped token, and then he can use that unscoped token into our service provider to list the projects that it contains, and user can then use any of the project he wants to access. So we also prepared a small demo how everything will look like after all this configuration, how K2K will work. So let me just start it. So first, we are going to create an user in our identity provider. So we're just using OpenStack CLIs and creating a user named as IDP user. We need to assign some roles to it. So we are assigning some roles to our identity provider, for our user in the identity provider. Now we are going to log in the horizon of the identity provider. So we can see that we have logged into our local keystone named as IDP user. We can check that this user exists in it. So after linking both these keystone, we'll have a service provider on the drop-down menu, and we have successfully switched to our service provider. We can see a shadow user is being created into the service provider, and user can now use the services in the service provider, whatever he wants to do, listing networks or creating instances. Okay, so next. This is the URL for our federated identity if you people wants to know more about it. So you can just go through the document in it. Now I would like to invite Colin to discuss the future of the K2K. Okay. Yeah.
Thank you. All right, so first of all, as we mentioned, Keystone as an identity provider doesn't currently support that web SSO profile. And so we would like to take that and turn Keystone actually into a first-class identity provider and adding that support, which would really enhance the usability of Keystone as an identity provider. And then once we have that, we can start talking about turning Keystone in what we're calling an identity provider proxy, which would be a way for Keystone to take identity information from all kinds of external identity providers, any sort of SAML provider, OpenID provider, translate that into something that Keystone can understand and supply that identity information to either other OpenStack services or to services outside of the OpenStack ecosystem. And we'd like to see Keystone turn into something that could be actually a standalone component. Something we're working on now is adding groups as an attribute for the SAML assertion that's generated by the Keystone IDP and making that actually be able to map groups from a Keystone IDP to a Keystone service provider, which is something we don't currently have yet. And then we'd like to build on application credentials, which is a feature we landed a couple of releases ago. We'd like to take those a step further and make those useful for federated use cases and especially for edge computing use cases so that application credentials could be used on an autonomous identity service on a remote edge site when there's not necessarily a reliable network connection to centralized identity services. And then finally, an idea we've had for a while is to implement native SAML on the service provider side of things, which would eliminate the need for the complicated Apache setup that we have and make Keystone, the service provider, more of a self-service thing, allow, for example, public cloud users to be able to configure their Keystone instances in a way that that's more self-service and more usable. And that concludes our presentation. Thank you, everybody. And we have some time for questions, too, if there are any. And there's a microphone in the middle of the room. All right. Well, thank you very much.
Thank you.